We all know what this looks like. You type a question into Chatgpt, what is the capital of France? And a full sentence magically appears. The capital of France is Paris. But under the hood, it never actually writes a sentence. It doesn't even think in sentences or thoughts. It plays a much simpler game. Given all the words so far, guess just the next word. That's it, over and over. Let me show you what's really happening when we ask, what is the capital of France? Inside the Chatgpt, the model sees this whole prompt, and then it tries to predict the next word. Maybe it thinks the is pretty likely. It picks one word. Let's say it picks the. Now here's the key idea. We add that new word to the end of the prompt and send the longer text back into the model. So now the input is, what is the capital of France? The. Chatgpt looks at everything again and asks, given this whole sequence, what is the next word now? Maybe it predicts capital. We append it again, feed the whole thing back in, and repeat. If we keep doing this step by step, it might go like this. From the outside, it looks like the model just knows the answer. But mathematically, it's just playing this one game. Given all the previous words, predict the next one. In this video, we're going to do a little surgery on GPT-2. We'll open up this process, look at what the model sees, how it represents these words as vectors, how attention moves information around, and how it actually decides which word comes next. So we've seen how GPT-2 generates text one word at a time. But how did it learn to be good at that game? GPT-2 was trained on a huge amount of text from the internet, like web pages, articles, all kind of stuff. Take one document like this. The model doesn't read the entire internet in one shot. Instead, we cut these documents into smaller pieces or chunks. Each chunk is just a slice of text, and we feed these chunks to the model during training. Let's take a single chunk and see how we turn it into a training example. Say our chunk looks like this. We're going to split this into two sequences, X and Y. X is the input, Y is the target the model should predict, and Y is just X shifted by one word. So for every position, the model sees the words in X, and its job is to predict the corresponding word in Y, the next word. So let's walk through this step by step. The first input word is over, and the target is his. The model looks at over and tries to predict that the next word should be his. The next input word is his. So inputs so far, over his. The target output is friend. Now the model can attend to both over and his and try to predict that the next word should be friend. Third input word is a friend. So inputs so far, over his friend. The target output is Enkidu. It looks at all three words, over, his, and friend, and predicts Enkidu. This continues all the way through the chunk. Every training step is the same game. Given all the previous words in X, guess the next word in Y. And whenever the model guesses wrong, we measure the error and use backpropagation to slightly tweak all the weights. So next time it's a tiny bit better at this game. There's one more important thing. GPT-2 doesn't actually understand words like we do. It only understands numbers. To feed text into the model, we first have to tokenize it. Tokenization is a process of breaking text into small pieces called tokens and mapping each token to an integer ID. A token might be a whole word or a subword. GPT-2 uses a specific tokenizer that splits text into these tokens, and it has a vocabulary of 50,257 different tokens. So our sentence becomes a sequence of numbers. Those IDs are what actually go into GPT-2. The model never sees raw text, only these numeric tokens, which then get turned into vectors and processed by the network. In the next part, we're going to open up the architecture of GPT-2.